Let's go over the surface area of a sphere, not a sphere. Okay? The sphere is a circular or round three-dimensional object. So I've kind of drawn it this way. Another way you may represent a sphere. I had a contest last year and had students try to represent spheres the best. I like this one. Someone drew it like this. I thought this was pretty good. Oh, doesn't look three-dimensional? I thought it did. I didn't draw it very well. Either way, that's not important. When we're talking about the surface areas for a sphere, this is our formula. Okay, we need to know the radius of the sphere, and we pi r squared, which is very similar to our area of a circle. We then multiply it by the value of 4. So it's really just one more number than we're used to. So in the textbook, they have a really neat example. They talk about the surface area of an adult eyeball. Okay, so apparently dimensions of eyeballs are pretty consistent, and they vary within a millimeter. And the average diameter. Okay, so let's create our sphere again. So I have my circle, and I'm going to use this. I'll just move it up a bit. Okay. Apparently that the diameter, so that's the distance across the entire sphere, is 2.5 centimeters. Okay. So, if we were to calculate the surface area of the human eyeball, and we're going to try to be as accurate as possible, what is the one measurement we need? We just need the radius. How do we deduce the radius from this, Logan? How do we do it, Logan? We divide it by 2. So we're going to take this value, 2.5, and we're going to divide it by 2 to figure out the radius. What is it? 1.25. 1.25. Excellent. So the radius of this, say from here to here, is 1.25 centimeters. So let's take our surface area of a sphere, okay, which is 4 times pi r squared. The only thing we're going to replace in this is the r. So we have 4 pi multiplied by 1.25 squared. Which of the operations would we carry out first? Why the exponent? Because of BEDMAS, right? We look at brackets. Brackets, there's nothing I can really simplify here. Exponents is the next thing. So 1.25 times 1.25. 1.5. We're going to try to be as accurate as possible. 1.5625. Okay? So let's write all of those in. We have 4 pi by 1.5625. Okay. Now, unneeded. Not really. So, these operations beside each other, what operation are they? I have a number, a symbol, and another number. Yeah, it means multiplication. And because it's multiplication, it doesn't technically matter the order we multiply it in. So I'm going to keep the number I had in my calculator. I'm going to multiply it by pi next. Okay. And I'm going to multiply that by 4. So I'm very accurate here. 19.63. We're rounded to a tenth, which is 1 decimal place. So the surface area... Oops. So we're just going to round it to the 10th column. And because it's area, what is the final answer, units? Squared. Excellent. Okay, let's say we have this. They've given us the surface area of some object. So this baseball's surface area is 215 centimeters squared. We want to know the radius of this baseball. So what is the formula for surface area of a sphere, Char? Okay. Of this formula, what information do we have? Do we? The surface area. So we're going to replace our surface area with our value of 215. So we're going to plug in 215 for the surface area, which is equal to 4 pi r squared. And the goal in this question is to isolate for r. So one at a time, we're going to move things over. What's the first thing we can move over? 4, sure. When I move 4 over, what would it become on the other side? Because it's multiplication on this side, we're going to divide, okay? Now, what's neat about this is, because it's 4 times pi, I can actually bring both over at the same time and divide by 4 pi. So on this side, it would read 215 divided by 4 pi is equal to r squared. So I've moved 2 of them all in one step here. If that's confusing to you, just move one at a time. First move 4, and then after you get a value, divide it by pi again after. But this is the exact same thing. So let's work through that. 215 divided by bracket. So I got to put my brackets around this. 4 times pi n bracket is equal to 17.1. On your calculators, it'll probably be a lot easier to put together. 17.1 is equal to r squared. Are we done? Do we have the radius? That's right. We find the square root of this value, so the radius of this object, 4.13 we'll say. So 4.13.
3.13. That's the opposite of pi.
Oh, yeah. That's good, guys. So this is 4.13, and because it was centimeters squared before, and this is just a distance, it's just centimeters. We don't do anything else with those values. So that's everything we've done for surface area of the sphere.